Okay, so I don't think you have to see me, right? You don't care about me. I'll just do it in here. Come on, video. Okay. Uh, Here we go. And I'll just shrink this so we know more people come. Okay, how are we doing? So let's just do it. So let's start with the left off in class. Um, we did remember, if you have any questions, ask me or email me. I didn't look at my email actually from the weekend, but I will after class, after this review. So let's see what we got here. So we were in the middle of the review and we were up to, I think, oh yeah, here's the recording so far. And here we are. Where are we up to? So, all right, we did this and we did that, we did this. Uh, we did this. Oh, okay. Uh, oh, oh, so we explained over here that if you have a tier n tier pattern, that's an architectural pattern, right? Archi architectural pattern. So that means that if we look at this code over here, for example, which code would be at the bottom, which would be on top? Actually, let's just let's just do let's do class A. Let's just do it real fast. Class A, and then um, make it simple. Class A, and then we have class B, and then B within B, it uses A like as an object A, and then we have class C, and that's dependent on, say, as an object B inside of it, right? Okay. So in this example before, which class would be the top and which one would be the bottom? Anybody want to guess? Because which class is not dependent on any other classes? In other words, so for example, if you look at C, it's dependent on B. If you look at class, so the way it would work is the one that's not dependent on anybody would be at the bottom, right? So so looking at these three classes, A, I'm sorry, A would be at the bottom. So the top one would be C because that would be the top layer. And then the bottom layer, well, let's start at the bottom. Okay, the bottom layer would be, okay, in this example, the bottom layer um, would be A, because if you look at this code over here, A is not dependent on anybody, right? So that would be at the bottom. Then what's dependent on A? Well, B is dependent on A, so B would be above it. So B would be the middle layer, and then the top layer would be C, because that would be dependent on B, right? Because this would be the top layer. Okay, this is dependent um, on B, and this is dependent on A, right? And then A, the bottom layer, is not dependent on anyone. Does this make sense? The bottom layer is always the one that has no dependencies. It's the A has no dependencies. Okay, so that's how we draw it out. Okay? So the top layer is always the one that's dependent on every but the one beneath it. The middle layer, right? But the way we specified it was that A has no dependencies. B is dependent on A, so that would go over here, right above A, and then C is dependent on B, right? How many layers are there? There'd be three layers, right? Right, so below would have three layers. Okay? Okay. Next. Um, this I'm gonna just get rid of. This is like uh okay, let's do 23. Okay, 23. Forget about 22. It's too complicated. Okay, so what is wrong with this code over here? Anybody want to guess? Why does it violate the open-close principle? Anybody want to guess?
I guess like the last return isn't like indented correctly.
No, but it violates the principle, and it's not an issue of formatting,
Oh, okay.
right? Well, it's well, the problem would be what? Well, if
The
you read it,
parentheses probably be like
what?
in like the open parenthesis, like
No,
if doesn't have.
no, it's violating a principle, not the code works. It's good code. There's nothing wrong with it. It's just it's violating a principle, right? That means that it works, but it's a it but logically, I mean logically it works, but um, but it's not a good design. And the reason is because uh, it violates the open close principle, which means that, well, what does it say over here? That when we want it, right now we're multiplying, adding, and subtracting. But what happens when we want to do division? We're going to have to modify this code, right? And what does open close principle say? We're going to have to add another line of code for division, right? And we're going to have to change, right, this if statement over here to be subtract, right? We're going to have to modify the existing code to add another. Right now it does only three operations, right? Right. This does, this code performs, right, three operations. But if we wanted to do four operations, we want to add another operation, what would we have to do? We'd have to modify this method, right? That violates the open closed principle, which is what does that say? That code should be open for extension. I mean, this is a simple example, but that's the idea, but it's true. Meaning that if we would add another operation like division, we would have to modify a couple lines of code, right? So open for extension, close, and we might break stuff, right? For modification. What may break if we change it? For example, or what would change? Yeah, no, it's how could we introduce a bug if we added division? Anybody want to guess? Well, think about it. If we added division, right now the default operation is subtraction, right? So what is the new, if we had division, what's going to be the new default operation, right? So we might be changing, so code that might depend on the default operation being subtraction, might all of a sudden, we might change by accident, or we might want to change the default operation to be division, right? So by changing this code, we could actually break other parts of the code, right? Do you understand that? Does that make sense? So basically anytime you change code, things have to change, right? If we would add something here, something would have to change, right? Where would we put a division? After subtraction, would it be a default, right? We have to be careful, that we don't accidentally subtract and divide, right? So different things could break when we change the code. So it's better to add code, which is open for extension, rather than modifying existing code. Whenever you change code, there's a possibility something could break. Okay? There's no such thing as a abstraction principle. What's encapsulation mean? What does that mean? How would you describe that? Encapsulate means to what?
The
To
data
protect
will be
something.
private.
What?
The data will be private.
No, I'm saying, but what's the idea of encapsulation? Well, you tell me. I mean, what's the concept? That's what I was asking. The concept of encapsulation is what? You were saying it.
It encapsulate the data, I believe.
Right. You make it private, and by doing that, you encapsulate means you protect it, right?
Yeah. Yeah.
Like it's inside, it's surrounded by another layer of code that protects it, right? That hides it, right? I guess it's a better way of saying encapsulating is like to hide it, right? Encapsulation means to hide, right? So I'll just put that here. Encapsulation means to hide, right? Or protect/protect. Um, okay, so and then the singleton pattern, what does that do? What's the idea behind the singleton? Well, it's really nothing to do with this, right? Singleton deals with what? That we want to have only one global. Do you see there's no globals here, right? So it doesn't have anything to do with it. Factory pattern has nothing to do with this because factory pattern deals with what? The creation of objects, and there's no objects being created, right? They're just operations being performed, but there's no objects. So the only thing that would make sense would be the open-closed principle. An abstraction principle is I just made that up. It's not really such, there's no such principle. Um, okay. So over here, these are four unit tests. Okay. Now, assuming that the code works correctly, right? So, um, what's wrong with number, the first answer? What's wrong with this? Why is this not a good unit test? Does that, do you see what's wrong with this? Because what's the output of this test? The output is a print statement, right? So that's not very good for testing code, right? Because you have to watch what it prints. So it won't work automatically. You see? Does that make sense? So the first case would not be a good unit test because the result is being printed. Okay. The second one, what is wrong with this code? Well, it says assert true, but if assuming our code works, this will always fail, right? A unit test should always, you always hope it's going to pass, right? It should always return true, right? It should never fail, right? Over here, again, this is asserting false when it's really going to it should always return true, right? So this will always fail. And this is actually something that will always fail. So this is a good unit test. So when we add 1 and 2, it should not be equal to 4, and therefore it should return false. And that's exactly what we wanted to do, right? We want that we want that when we try adding 1 and 2 and we say it's going to be equal to 4, that will always be fail. So the answer would be test number 4. Okay? Okay. Next. Number 25. Okay, what is the example of? What kind of pattern? Singleton, right? Because there's a global ID, right? Because over here, there's a static private int, right? So that is a global, and that is a singleton pattern, right? Right? How is it protected? Well, somebody, forgot who said it. He said that because this is private, right? So it's a singleton, so therefore you can only access it by calling this method over here called getID. Okay, and let's see what else we have. Um, YouTube allows um, many people to subscribe to multiple channels. This is like which design pattern? Well, it sounds like the observer pattern, right? Because you have many people observing, um, you have many people observing different channels, right? So they're observing, right, that channel. Okay. Okay. So let's see. We have one. Let's match the left and the right. So the presentation layer. Does anybody remember what that is? The presentation layer is part of which type of architecture? Anybody want to guess? The what? The three-tier pattern, right? Right? Which is what? It's 3 layers, right? What are 3 layers? What are the 3 tiers? Oh, actually, it says over here, right? They are 3-tier architecture is um, is basically the is basically presentation layer, business layer, and database layer, correct? So that would be the first this one over here. Let's do this A would match. That wasn't a good idea. Um, I don't know what he broke, but uh, anyhow, so um, basically, so the idea is that the presentation layer matches the 3-tier architecture. Let me just put that over here and put this over here so you can see that. Okay. Um, the except the con is confusing, and this should go like, uh, I don't know. Maybe let me just um copy this to Word and I'll put it back in normal. Um, Okay, so yeah. So we have the on the left we have the A, and then we have the B, and we have C, and we have D. Okay. And then on the right we have one um eh, uh more of that. And why is it going over the we have the I'll just put this back here. This over here we have just trying to make this clear. Okay, so over here we have the user story, which is usually which is usually a combination of these three things, right? And then we have the controller layer, right? What is the controller layer part of? Well, this one is pretty obvious, right? It's right over here. Model view controller architecture, right? What is MVC pattern used for? What is MVC used for? What type of software uses it? Does anybody remember?
What application?
Right, for web servers specifically, right? The web server, right, would use the MVC, right? Um, and then so B would be two, C would be software validation, um, which is that would be unit testing, right? What does TDD stand for? Remember what that stands for? Test driven development, right? Which is another way of saying a unit test. Okay. And so software requirements would be number one, right? Right. So, so again, so A would match three, B would match two, because it's pretty obvious. C would match test-driven development, because they were talking about validation is another way of saying testing. And software requirements is basically number one, which is who, what, why. Okay? I apologize for the messy format. Let me just put this back in to the other document so we have it. So, okay. It's a little better, I hope. Okay, what else do we have? Okay, what is this over here? What kind of diagram is this?
Sequence diagram.
No, no. Sequel? There's no
No,
sequel.
sequence.
A sequence. Oh, very good. Oh, okay. Very good. Right. Excellent. Right. And what is the guy? What is withdraw money? What is that called? It's called a actor. What is this arrow over here called?
A message.
A message, right? What is this over here called? Bank database and ATM. What are they called?
Lifelines, I think.
Right. Very good. Right. And what is this dotted line called?
Or a reply or a response.
Right. Return message. Right. Very good. And what are these blue things called? Well, what do they represent? Oh, yeah, actually, both. What are they called and what do they represent? They're called activation bars, right? And then what do they represent? The passage of time, right? So, for example, this one over here would be activated the most. This actor, the withdraw money actor, right? And how do you know where to start and where to end in the sequence diagram? Where do we always stop and where do we always end? How do you know where to, we start from ATM, we start from bank database, where do we start and where do we end?
We start from the actor, no? I think.
Well, not well, in this case, I guess so, but it's more basic. It's we always start at the top, right? And we go down, right? So as time goes on, we just follow from top to bottom, right? So you know, you'll never find two messages at the same time, exact same time, right? There's a sequence. That's why it's called sequence, right? First, you send one message, and then another message gets sent to another from one object to another, then a return message and another return message, right? So there's a sequence of messages, right? So there's a right. So first is this message, the topmost, and then the last one will always be the bottommost. Okay? The database is needed to withdraw money. That is true, right? Because otherwise you can't withdraw money because it has to check for sufficient funds. The object it takes the least time is the actor. Nope, the actor actually takes the most time. There are no return messages. Nope, there are two return messages. Withdrawal request is stored in the database. The withdrawal request is actually over here, not in the database. It's actually stored in maybe the ATM, I guess, but it's not in the database. ATM database is a relationship. That's not true either, right? ATM database they just communicate with each other. They don't have a is a relationship, right? What is a relationship? What type of relationship is a relationship? What would you say?
Was it inheritance?
Exactly. Very good. Okay. 30, question 30. Very good. So they don't have, there's no inheritance. We're not showing inheritance, right? It's a different type of, what type of diagram shows inheritance? What's that called?
Has a,
Say again?
has a. No, wait, what was the question again?
No. I'm sorry, I said database. What type of diagram shows inheritance?
Uh,
I'm sorry, there was yeah.
the UML diagrams.
Which one?
Does a UML diagram show inheritance?
Yeah, but these are all UML diagrams. A UML class diagram, right?
Oh yeah, okay.
Okay, class diagram. Okay, the following will usually cause code to be refactored. Changing code leads to code refactor. Meaning, okay, what will cause code um to be like what does refactoring mean, by the way? Refactoring means what does it mean? To fix code? How would you translate it? What would the best translation of
Like
refactor?
rewriting the whole code or
Yeah,
re
but what are you doing? Are you fixing it? Is it broken?
uh I think no, because it's getting old, no? Or something like that.
Okay, so what are you doing? You're cleaning it up, right?
Yeah,
Refactoring
yeah,
means
clean it up.
to restructure it so it's clean, right? Making it clear. So so what will cause code to be have to be cleaned up? Well, when you make a lot of changes. So changing requirements, incremental development, which means we're making lots of changes, new features, all these things. So the answer would be number four, all the above, because all these things introduce changes, and when you change code, you frequently have to refactor the existing code so that the new code will be clear, right? Um, this is just stuff we from chapter 8, I think, which is different levels of testing. Do you remember what these are? What's the difference between release testing and the first three, A, B, and C? System, component, and unit testing. What would you say the difference is? Well, I said in parentheses some of it, but you remember like there's a big difference between C and D. Well, A, B, and C are done by who? Who performs this testing?
by the developer.
Right, development department, right. But D is done by somebody other than the developers because we're actually not looking for the same things, right? A, B, and C are looking to make sure the code works. D, what is that making sure?
That every feature is in there.
Right, right. Making sure that the code works as expected for the client, right? So it's a different type of testing, right? We're not looking to make sure it doesn't crash. And then there's E, which is again a different type of testing, because that is when the user is testing it, right? No, the user is testing it. We're giving them it's like a test drive of a car. Right before you buy the car, you should take it for a test drive. I've made that mistake many times, and I've you know I've gotten cars that not many times, but one time I guess I did it. I never drove it before, and I got it, and I was like surprised um, how low to the ground it was. I didn't like it. So thank God I got rid of it. I was able to get rid of it. Like I switched it with something else. But yeah, but you should always, right? You should always, before you, or in this case over here, when you have software, before you pay for it or say, we're okay, you want to look at it, right? Test it out. Make sure it works the way you want it to, right? Okay. So, over here, okay, this is just, we mentioned that it's much cheaper to fix code the earlier it's found. And there was a bug, it's cheaper to fix the earlier we find it, right? Um, that's why it's always more cost effective to test code than it is, to write like unit testing when the developer finds a bug than if the customer finds it. Besides being embarrassing that the customer finds a bug, but it's also much more expensive to fix, right? So, so therefore, it's very cost effective to fix it. So, what type of arguments will cause code to crash? Um, okay, so this is called guideline-based testing. Okay, which is basically these are like stuff we know from experience or we've heard from other people that well there are known things to cause code to crash, right? Like for example, actually I'll add another one. So one is, for example, if you pass in no values at all, like a null value, or a very large value, very small value, or something that causes an endless loop condition, right? So these are things that we know um, that endless loop, right? So these are things that we know about that cause code to crash, right? These are like common mistakes, like um, like for example, certain companies, certain software, you're not allowed to write like a while loop or something that might never um, or like you're not allowed to do what's it called um, uh, uh, in a code that's um, I forgot what it's called. But anyhow, but certain types of code they might never end, right? It's the code that relies on a certain condition to end the loop, right? And it might not end it. It might keep on going. So and then the program will crash or something bad will happen. Okay, then we spoke about partition-based testing, which is a different type of testing. So again, the one type of testing is called guideline, where we rely on things like, a large amount of data, small amount of data, like, different amount, the different things that might make something crash, right? Partition based is where we test the edge conditions, right? So for example, we'll make like three tests. One will be less than what is expected, one is more than what is expected, right? And we'll see how the code handles that. And then three, we'll pass what is expected. So in that case, we could, if we do these three tests, we pretty much covered all the possibilities. In other words, you don't have to write a million tests, right? But what you do is you do the edge case. Edge case means, like, let's say we're expecting a number that's between, let's say, 1,000 and a million. So we pass in, let's say, 999 and maybe 1,000,001 and then maybe 100,000. So we pass in one value that is less than what is allowed. I shouldn't say expected, than what is allowed, and see what happens. And test two would be more than what is allowed. And then test three would be like what is allowed. And we make sure that what happens in all these cases. Okay. So this would be an example of a partition testing, okay, where we're testing the edge. You understand what it means, the edge case? In other words, we're testing at the very edge of what's acceptable or not, right? That's called an edge case. Okay? Does it make sense? What's in it? What an edge case is? Okay. Next, we're doing not true about unit testing. Allows testing to do parts of the software. That is true. Team can execute unit testing before the completion of the entire process. Okay, that's not really important. I don't think we discussed it even. Um, Actually, yeah. Okay, I'll leave it in. Three reduces the cost of development. That's true because we said increase reliable code. That's also true. So then number five, the part that's not true is five because testing interactions between various parts of the code, that's called component or integration testing, right? That's not unit testing, right? Unit testing is we're testing parts, little parts of the code by themselves, right, to see how they work. And then the interactions between different parts of the code, that's called either component or integration testing. Okay? You get it? It's called integration because we're integrating give different objects together to work together. That's why it's called integration testing. Okay, 32. What architecture is associated with a web page? Well, layered pattern, that's not really it's not necessarily a website. Pipe filter pattern, do you remember that? That's more like a compiler. Model view controller, we said, oh, actually, I wrote in the comments. This is for a web server. I should put this over here. That's not really a web page, right? And tier pattern, that's really not really anything to do with a web page. That's a general architecture for an application, right? General application architecture, right? Now, um, but client server would be the answer because every web page is a client of a web server, right? Any website you go to will always be a client of a web server, right? That makes sense? Which architecture is associated with an email program? Well, you basically just said it. It's the same idea, meaning client server, right? Because every email program, there's a email server somewhere in the cloud, and my email program is communicating with that server, right? The email server. Three, okay. What does A represent? Right. What is which? First of all, which does that which architecture pattern is this? Do you remember this? How many? Okay, let's start from the very beginning. How many layers are there in this design? Oh, by the way, before the some companies they don't allow it's called recursive programming. Okay, that would be like they don't allow that because well, number one because it might never end, and number two because it might blow the stack, right? So because you don't really have control over the recursion, right? Did everybody take recursion like in 10? You probably did, right? In 101 with Dr. Riba or Reba, right? He does recursion. So that could really either never end, right? If you don't do a correct base case, or it could be a or it could just be like it'll just blow the stack because it's so many calls to the base class. So either one could happen. So a lot of companies will not allow their programmers to write recursion. Um, okay, back to this. So this is called a three-tier, right? The bottom is the database. The top is the what's A? Anybody want to volunteer? What A is called?
Presentation layer.
Exactly. What is B? Come on, you got the first one right. What's B?
Um, um,
The business layer, right? So presentation, business, and C is database. Okay, so what was the question? So yeah, the answer is that A represents the what you see on the screen, which would be what? The presentation layer, right? I said ignore the cloud. Right? So the cloud's a little bit confusing. Um, I remember like everybody when the internet was like newer, they had all whenever you had a business diagram, you'd always have a cloud for the internet. Yeah. But now I think it's more like it's not so you don't need to do that. It's obvious to everyone that that's being used. Um, okay. Because actually nowadays nearly all software is in the cloud, pretty much, right? So um, I don't think anybody writes software nowadays um, wants to write it for for a desktop anymore. They pretty much everything is, they like it to run on the internet. Okay. What type of testing would a developer probably do? These are different types of testing. So what's in between black box and white box testing? What would you say? Black box does what? Black box means what's a black box? Right, we always refer to code as like in a black box. What does that mean? Meaning that what?
I mean, we don't know the detail of the code.
Right. We don't right. We don't know. We don't care. Right. So now the idea of a black box is that, like for example, let's say I go to a website and I order something. Right. So that's a black box. I don't know how it does it, but I don't care. Right. So if you do black box testing, you're basically actually I shouldn't say developer hitting from the tester. Right. So white box would be the tester, um, the code is not hidden from the tester. Okay, um, so that would be so the question is what type of testing would developer probably do? They would do white box, right? Because they're a developer, so they can't anybody could do black box testing, right? when I say hidden from tester, I'm sorry. The code is hidden, right? So, um, so the probably the developer would do white box testing, right? Because they're available. They're exposed. But I have to call them back. Okay, because right, because developer usually of anybody right. Well, let's see the other options, but usually right, a a developer would have access to the code, right? But a black box, anybody could do that, right? Right? I could test Google, right? Search, right? I could do that right now and test it, see if it crashes, right? Anybody could do it. It's a, because that's black box testing. Um, okay, I could test this program over here, Google Docs, right? I could try crashing it, and or I could probably make it format incorrectly, right? That's probably not too difficult. Okay, acceptance testing. What type of testing is that? That's not going to be done by a developer. It's done by the client. Release testing, we said, is what? Remember, we said right before, we said it's done by the another, not the developer, right? It's not done by the developer. Okay. And then uh, graphical user interface. Who's that done by? That's done by who? Well, that's usually the GUI or the right or the what people see, that's usually done by um somebody who does that type of thing, right? Usually not a developer, right? Um because again, it doesn't require anything that developer has no special knowledge that would warrant them. Okay, if I want to test a divide function using guideline-based testing, I already tested one divided by two and it correctly returned zero point 0.5. What are the values should I test for in the denominator? Like, how would I try to make this crash? Right? How would you try to do make something crash?
Zero.
Right. Divide by zero, right? That's a good old fashioned way of crashing code, right? So, yeah, I wonder if let's try this in Google. Um, uh, let's try, uh, what is result of a 6 divided by 0? Okay. I think it had to think a little bit more about that, right? Uh, It's they say it's undefined or it's infinite. I didn't know that. So, okay. What did you think something divided by zero was? Under
I think it's always undefined.
Really?
So yeah,
I always thought it was infinite.
and so in some cases probably, but
Okay.
usually it's undefined.
I'm not a big I don't know a lot of math though. I okay, whatever, but you always get them in programming usually when you do divide by zero. Oh, actually sometimes it says divide by zero error and sometimes like in the old C++, I think it would give you I'm not it would give you like a I think it would give a user it would actually give like a like number too large type of answer like I seem to remember. But I think like Java right away, they check for it.
I
And
think in C++ it gives you like a yeah, well, a large number,
yeah,
so something negative
it'll
large
give you
number.
overflow, right? Large number
Yeah,
overflow. Yeah, I think so. Yeah, so that's why I thought maybe that the answer is infinite. Um, okay, So these are stuff to know for the final. Uh, these are just general things. I just basically went through the chapters. Um, Ethnography, this was like chapter 4, which is what does this not, ethnography mean? It means like what? It's like
Like understand the environment that we're
right.
trying to make the
It's like,
program for.
in other words, like besides knowing the requirements, but understanding like what would be an example of ethnography?
Uh, I don't know if you're like trying to make a program for an hospital or something.
Right. So why would that be different than for a business? Like in what way?
Uh, because
Maybe
we
there's a
like they
lot of
have different requirements and like
no, we're saying with the same requirements, but if the environment is different, like I'll give an example, like you just had a good example, like a hospital, right? Hospitals have a lot of noise, right? A lot of beeping going on. So if you're doing it for a business, it's one thing if your software gives a beep, right? But if you're gonna do it for a hospital, you don't want it to beep because everything is beeping, right? In the hospital, the whole, you walk in, it's going beep, 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 right? And there's always I don't know if you've ever been in a hospital, but I've been in, I think I've never been in one as a patient, but I've visited a lot of, many times different people, and there's a lot of noise, a lot of beeping, right? Beep, beep, beep for, the heart monitor, and then the IV, whenever it gets low, it starts beeping a lot of beeping, right? So you wouldn't. So if you're doing something for business, you might want to do a beep, right? That makes sense. But you wouldn't do that for a hospital, right? So that's like an example. Or like, let's say software is going to be used, let's say in the desert, right? So or not desert, like somewhere where it's very bright. So then you wouldn't want to do like fancy. You would do more like something that would work with, in bright sunlight like with high resolution, like you wouldn't do like something that's very delicate graphics, right? You would do something that it's easy to see in the sunlight. And the same thing, like if it's in the dark, right? You would want something that you probably want something that could be dimmed, right? Stuff like that. Um, or if it's used by people who don't have keyboards, right? They only have, they can only use their fingers, right? So then maybe you'd make it easier, right? If you know they don't have a keyboard, so then you would maybe make it easier to use, just using fingers, using touch rather than, typing in stuff, right? So those are all examples, right? Um, Software evolution we spoke about, or is actually chapter 9, right? With basically new versions of software, right? So that's actually I put that over here. This is really actually this is not software evolution. This is software maintenance. But I don't know. Evolution just means like new versions, actually. So actually, no, I'm sorry. Yeah, that's not same thing. So this is software maintenance, and I spelled it wrong. This is chapter 9. So this is chapter 9. And evolution means like basically you're just doing a new, I don't even know why I put it in there. Uh, but that's what it means. Okay, software evolution means that we're doing new versions of software, either their maintenance uh, releases or feature release, right? Right. But okay, I'll just keep it simple. New version of software. It's just a fancy word used by our book. Okay, the diagrams, right? All the different types of diagrams. Look at chapter 5, and you can look in the folders. We have all different diagrams. Um, the difference between state and activity diagrams, that the basic idea is that you have to be careful what a state diagram is. So, like a state diagram is showing you the different states of only one object. So, activity diagram is not really showing you only one object. It's showing you, different things that are happening within your program. So, so basically, the state is like focused on the low level transitions between different states. Does that make sense? So, for example, um, like where are we? Um, for example, state a diagram of let's say of a door. So that would show you one door, and it will show you that. Okay, here I don't even like it. The way they did it was they have. I don't like the way they did it. Um, they did it that where is it? What is this doing here? uh, okay, so over here they have a state diagram of a door closed and door open, and they have a door opening state, which I don't like because I don't know what that means. It's not really a state. Uh, and then they have a door, if it's opening, they have a door closing state. Um, okay, I don't really like that. But I really like just door open and door closed. I don't, because the verb closing and the verb opening is not really a state, right? It's really what's happening. So you're transitioning from door closed to door open through the door opening, but I would disagree and say that door opening is not a state and like they're mixing up the two ideas. One is an activity, right? And one is a state of the object. So the door is either open or closed. And yeah, this would be an example I would disagree with, right? There's no such thing as a door opening state. It's a verb or a door closing. It's not a state. It's a verb. Okay, so that's basically what my pet peeve is that I was talking about over here. That state is telling you, like, for example, water could be in water, vapor, or ice, and activity is telling you, well, different activities that could happen, right? Like, for example, so I would not say a door opening would be a state. It's just something that happens with the door. The door could open and the door could close, right? Just like I would say, like if somebody walks down the street and then a person drives a car and a person goes to the store, I wouldn't say those are different states. I would say those are different activities. You know what I mean? Whether a person is awake or sleeping, I would say that's a state, right? It's more, right? It's more limited to what the person himself or herself, rather than what the other like the possible things that might be happening in the program. Okay, that's my personal opinion. That there are a lot of that it gets very confusing when you start calling activities states. Then it gets very confusing. Like then everything becomes a state. Anything could be an activity or a state. And then the whole thing gets really confusing. So I say state means when you're looking at one object, what are the different uh, conditions it could be in? Like, for example, a person could be, let's say, awake, sleeping, maybe tired, maybe happy, excited, sad, etc. Those all, because they're all looking at the person. But like if a person is walking down the street, or a person is like driving a car or flying an airplane, I would say that's not a state. That's just a activity the person is doing, right? We're not, that's a person interacting with different things. Okay. Anyhow, that's the way I taught it in this course. Okay, pipe filter is this is a architecture where you have a bunch of separate programs where the input of one program is the output of the other. Meaning that you have, let's say, um, like for example, you have in C++, you have a preprocessor, and the output of the preprocessor is the compiler, is the input to the compiler, and then the output of the compiler is the binary files, which are the input to the linker, and the output of the linker is the executable. Okay, static in Java is another way of saying global. It's actually also in C++, I think it's confusing, right? Sometimes it means global and sometimes it means for this file, right? I forgot already C++. But if I think to remember, you could have the same variable on different files, right? Am I right about that? And there could be different globals, right? You uh but in Java you can't do that. Okay. Um Anyhow, but that's the idea. The idea is that if something is static, it means it's global, meaning that um, what's another way? How would how would you say something is global? How would you define something that's global? Anybody want to venture? How would you define a global anything? A global object or something? What does that mean?
If it can be accessed by other by every class
Right,
or
right. It's global, right, exactly. Right. And also it's usually which means in another way, and also included in that is that it gets created right when the program loads, right? Because if it's be accessed anywhere by everyone in the program, it means that it has to always exist, right? So a global variable means it's well, generally it usually means it's created when the program loads, okay? Not always, but in general, right? Uh, well, yeah, okay, yeah. For example, even with, okay, okay, I won't get into it, but that's the idea. The idea is that a global variable is something that's accessible by the whole program, and and part of that means that it has to always be around, right? So usually that means it's created when the program gets loaded. Okay, with singleton it gets confusing a little bit. Okay, so okay, review productivity. Okay, we already said that in C chapter 5. Web browser always uses client server pattern. Remember which no, okay, so we spoke about the different non-fun this is chapter this is um architecture. What chapter is that? That would be 7, I think.
I think
Wait,
six,
what? 6?
six.
Okay. Yeah, so the architecture chapter. So we said that it was very interesting is that certain non-functional specifications determine the architecture. Okay? So for example, if our non-functional requirement is performance, then we want like for example, we gave like you can't have let's say a Tesla which needs to make immediate decisions to have to communicate with a server on the internet, right? Because then there might be some delay or there might be something blocking the internet, right? So it's not going to work, right? So if you need performance, you need you need code to execute. So usually the architecture is going to be that the code's going to be together, right? Won't be like some code will be running on some other platform somewhere, right? Um, Safety. If you're worried about safety, right? This is from the book, by the way, is that you should, but I mean, it's logical, is that you should put the code that has to do with safety together so you could see, make sure that, if you have the logic, the safety logic throughout the program, it's hard to really understand how it works. So it's good to have all the safety code together, the code that controls safety, so it's easy to understand what's going on, right? Rather than have it, very confusing, uh, right? And then things sort of break, right? Security. What does security mean? What do you mean safety and security, by the way? Does anybody know? Security means safety means actually safety, right? Mean that no one should get hurt by the software. Security means what? That the um that um the code is protected from outside, meaning that for example, right, that when our this document, right, is a secure document, meaning that only people who have access to this website could view this Google Doc, right? All right, people who don't have access to this, well, everybody does, but assuming, let's say, only people in this class had access to it, right? So security would mean that no one else would be able to see this document, right? It would be a secure document, right? Safety, you would say it's a safe document, right? Because that would imply that no one gets hurt by this document, right? Secure document means that it's safe from other people, okay? Maintainability means that code. Oh, so if you're dealing with security, the um, generally, remember the example I gave from like Queens College, that you just like when you want a building to be secure, what do? Usually you put a fence around it, right? Now, as you go around the perimeter, and that's your security layer, usually, right? Maybe you have more layers, but usually the first thing you're going to do is put a fence around you know, your whole the thing you want to protect, right? Right. That's why Queens College has a fence around the whole building, right? To protect, you know, to to well, it's a little bit different because that's actually safety. Why they put the fence. Uh, but the idea is like security is sort of like the safety of Queens College, meaning that just like you have a fence around Queens College to keep people from unauthorized people from going into the college. So a program will usually have a security layer saying that that you're not allowed into the program until you pass through the security layer of the program, right? Which could be capture key, could be two factor authentication, stuff like that. Okay, so um, that would be that's how security architecture would be, right? You would have an outer layer, which the sole point of that layer would be to protect who's allowed in and who's allowed to enter and access your code. Okay, so that's a common architecture. If maintainability is important, right? Um, it's another, um, it's a non-functional specification. So if maintainability is important. So then it's better to have small or large methods, right? Why are small methods safer for maintaining code? Does anybody want to guess? Why would you say smaller methods are better than big methods?
because they're easier to like uh fix or
Well, yeah, close, right? They're easier to understand, right? Because if code doesn't do too much, then it's easier to understand what it's doing. And number two, if you make a mistake, you're only gonna break, you're not gonna break too many things, right? So it's safer, right? And there's, let's say you have a module, let's say in your car that controls the transmission and everything, the lights. So if you make a mistake, you turn you put the something in the wrong way, everything could break in your car, right? But if you have something only controls, let's say the door, and then something only controls, the lights. So then there's less um, um, it's safer when you make a change, then the liability is limited, right? There's less that could go get broken when you make a change. So two things. Number one is it's just easier to understand, right? When you have something that does less, it's easier to understand what it's doing, right? Right? If you have a method, all it does is, one thing, then it's much easier to understand than if it does three things, right? And number two, if you make a mistake and you create a bug, right? Then it's then the most the potential for breaking stuff is much less than if you have code that does a lot of stuff. A method is a lot of stuff. Okay, so and then this is from Scrum. We spoke about this is from before the midterm, with the product backlog, which is like the wish list. The Scrum backlog is what we do each sprint. The potential release candidate that every time we go through it, we should have uh, uh, a potential releasable code. The daily stand-up is that we have a daily meeting. It's called a stand-up because we want to, get through it quickly. And then we said that when discussing incremental agile XP Scrum, it's all the same. So I don't have to worry about, um, they're all like the same. We treat them all the same for this course. Um, these are the different object-oriented principles. Do you remember what SOLID stands for? SOLID stands for single responsibility principle, right? Which means what we just said actually above that coach only do one thing, right? So, and we explained why, because it's easier to understand and less dangerous to change. O stands for open closed, which we said earlier stands for the code should be, it's better if we add to code than modify code. Open for extension, closed for modification. L stands for Liskov substitution principle. Does anybody know what Liskov substitution principle does? It says that if code works a certain way for a parent of an object, it should work the same way for the child of the object, right? So the child should not change the behavior of its parent. I stands for um, the interface segregation principle, which basically says you shouldn't have unrelated objects or methods in an interface. D stands for dependency inversion principle, which says that objects should be as general as possible. Yagni stands for you aren't going to need it, which means basically do two things. Number one, you're it means you're not going to need it. So number one, get rid of code that's just lying around and not being used because it's just confusing everyone. It's taking up resources to maintain it, and it's not being used, so get rid of it. And number two, don't design for future requirements. I mean, for what you think, what no, it's don't try to anticipate what requirements are going to be. No, it's wait until you get the requirement before you write the code. Because when you write before you write get the requirements, then you're 99 percent of the time you wasted your time because you wrote code for because you anticipated certain requirements and then the actual requirements are different. Try stands for don't repeat yourself. And why is that important? Not to repeat yourself? Does anybody know about that? Well, why shouldn't you repeat yourself? Because why? Well, when you repeat yourself, what's wrong with that? It's actually, if you repeat the code, it actually runs quicker, right? Um, so because why? Because we're afraid if you have the same logic repeated multiple places, you might change it in one location and forget to update it in the other locations. So by having all the code together, then when you change it in one place, you know you changed it throughout the program. And prefer composition instead of inheritance, that generally means that we don't like inheritance as a rule because inheritance in general is very strong cohesion, right? It's very sticky, meaning that whatever the parent, a child is a parent, um, so it's a is a relationship. So the child is also the parent. So when you change the parent, you're forcing the child to act a certain way. So it's very it's very that's what we don't like about inheritance. Inheritance is very it's too strong of a relationship between two objects, right? It's forcing the other object to act a certain way when you inherit from that object. I'm sorry, when that object inherits from you, well, if B inherits from A, B has to do whatever A does. Or by default, it's going to do whatever A does, and um, and that's too strong of oh yeah, that's the word we use. It's a highly coupled relationship, right? Very strong relationship between two objects, and it's not healthy when it comes to programming. Okay, sometimes it's good to have a strong relationship, and that when it comes to programming between two objects. 13, similarity with abstract. Yeah, and in general, we like things that are as general as possible. It's either abstract types or interface types. That we like those because they're general. And what does dependency inversion principle say? What does it say? Does anybody remember? It's always good to have general um, types because when we use more general types, what happens? There's less possibility for there's less no there's less of a chance that code will have to change. Then we spoke about nine. We spoke about seams. Seam is a um, it's sort of like a place where you could like test code. So if all the code logic is together, then it's hard to test every part of the code, right? But if we could like have a seam, meaning we could rip the code apart, meaning that the code is like and it has different methods doing, um, so basically, if we don't cram all the logic to one method, then it's easier to test the logic, right? Because if we have a method that's 100 lines of code, how are we going to test every line of that code? But if we have, say, a method only has 5 lines, much easier to test every line of that code, right? So that's the idea of a seam, right? To be able to test all the code, right? Not having everything squished together, and then it's really, or maybe even possible, or it's very difficult to test all the code inside a method. What is the side effect? Anybody know that? What's an example of a side effect? Again, we're only dealing with software engineer. We're not talking about, in general, like medicine, what a side effect is, right? Okay. There's actually a side effect is actually it's probably spelled it probably should be an A, not an E, right? Something that affects us. That's really what it means. So what's an example of a side effect? Anybody want to volunteer? So, for example, a side effect would be like let's say a program that writes to an operating system or that um, reads a file. So the side effect would be that the having to read or write um, to a file requires that if you're reading that file be there, and if you're writing it requires the ability to write to a file, right? And when we test that might um, make it hard to test to write a unit test, right? Because why? Because um, the because when the unit test runs on the server, who says the server has that file, and who says the server code running on the server has permission to write to a file system, right? We don't always have that permission, right? So basically, we tried to remove side effects so we could just test the actual the core logic of the code, right? The stuff that runs with it, we try to remove from the unit test. So we could just test the logic of the code that we're writing. When should you fix the code? When should you replace the code? So we said that generally, you know, it's like fixing a car. Like you have to make a judgment call. Like you know, if you just got a new car, so if it got a flat tire, you're not gonna get rid of the car, right? But if you have a car which has, you know, 250,000 miles on it and the transmission broke, you're not going to fix the transmission. You're probably going to just get a new car, right? Because at that point, it doesn't pay anymore to keep on fixing it, right? So fix the code is like basically, when the code is pretty working pretty well, just needs a fix. And re-engineer the code is when you have to make a major repair, but it's still worth it. And replace the code, that's when it's really, really, being held together by band-aids. In our case, in my company, they're getting rid of the code. We're replacing our code because Microsoft decided not to ended support for a system. So the people in the company decided to just get rid of the current system and get a new system. So because it's basically Microsoft is not going to be supporting it, right? So okay, what is a legacy system? So basically, what legacy basically means it's like a what's the word? A vintage, right? You say something is vintage. What does that mean? Basically, anything that's old, it's been around more than a minute, is could be called vintage, right? Or legacy, right? So a legacy just means it's something that's been around for a while. Okay. Usually, legacy system means that it's like something you wouldn't have asked for, like nowadays, right? Like, for example, let's say you have a car that's like a 30-year-old Corvette, right? So you wouldn't normally go ahead and buy that type of car. But now that you have it, right? So you have to either decide to keep maintaining it or just get rid of it, right? So it's basically something you're stuck with. right? Someone gave you this old car or you inherited it, and then you have to decide whether you want to do with it, right? What is the biggest problem with replacing legacy systems? So we said this on last week. I think we said on Tuesday, is what? Is that because normally there's a lot of logic that goes into a program which no one bothered to document, right? Very few systems are fully documented, right? So there's a lot of code that's, yeah, that someone wrote 20 years ago, they left the company, and you have this old system, and you try and replace it, but you don't even understand what the system does or why it does it, and you don't know if it's important. So that's the biggest problem with an old system is that we're not sure we're not sure what it does exactly or how it does it, right? Because usually an old system has a lot of, it's been around for a long time, has a lot of people, over all those years. If you think about it, right? If you have, let's say, people programming on it for, let's say, 40 hours a week for 20 years, that's a lot of changes and a lot of code, right? And a lot of changes that have been happening over the last 20 years. And probably the people who wrote it 20 years ago, they left already, and no one really knows even what it does. So, or why it does what it does. So that's the biggest problem with the legacy system, is that is the data, um, the lack of knowledge about the system, the lack of documentation and understanding what it does and why it does what it does. And then last but not least, what is corrective, adaptive, perfective, and preventive? So what's corrective mean? Well, these are like the four steps of maintenance. So corrective means what? Means that what? That we're going to trying to fix a bug. Adaptive means that it's not really a bug, but we're trying to keep the system, adapt to different environments. So, for example, if we wrote a program that runs on Windows, an older version of Windows, and a new one comes out, we wanted to make sure it still works. Perfective is, for example, we want to add new features, right? And preventive means that probably very few companies do this. The preventive part is either like documenting code or even like making code, refactoring it. So the code is better understood, what it does. But like no one ever gets points, no one gets an award for writing preventive software, right? They usually get an award for perfective because that's what the people notice, or adaptive. But when you fix a bug, the first and last ones, when you do corrective over here, or you do uh, so fixing a bug, no one, gives you any credit because, you just fixed a bug. You didn't actually add new functionality. Preventive, also no one really cares about until because um, like because it's not obvious to the users of the system that, wow, our program is really written with really well documented code, right? They don't care, right? Either it works or it doesn't work. They don't care how it's written, right? I mean, they will care eventually when they want to, you know, fix it or something like that. But in general, preventive especially tends to no one's interested in doing it because there's no upside to it, right? You tell your boss, "Hey, I just made the code more, um, I prevented it. I made it more." Um, uh, what's the word? More stable, more durable, more able to, let's say it's more secure. So they'll say, well, we didn't know it was there was any problem with it in the first place. So so don't waste our money, right? Doing things that we don't, that we don't even know is a problem. So basically, preventive never gets any credit in a company. So maybe the engineers realize that, but not none of the business people understand that or appreciate it. Okay, so basically I was gonna just go through the different folders. Should I do that, or are you all burnt out? I was just gonna just quickly go through all the folders, or maybe does anybody have any like specific questions or? Okay, so I don't know, I'm a little bit. You want to just call it a day, and then you could just go yourself through all the folders. Um, hello, anybody? Okay, so basically, I'm just going to go through the rest of the folders. I think you could just do that yourself. If you have questions, just email me before, obviously, Tuesday evening. And say have a good evening, okay? Then we did a lot, but just go through all the folders, make sure you understand the stuff, and also um, do um, the upload your presentations, um, the stuff that was presented after the midterm. Uh, there was very few stuff presented before the midterm, so pretty much everything here is going to be on the midterm. Could be on the final.
Professor, even the folders before the midterm,
What?
we have to review the folders even the folders before the midterm, right?
Yeah, yeah, but most of the test, 70% of the test is going to be on the after the midterm.
Okay.
Most of it's like from chapter 4 and on. That's what I focus on. Okay.
Professor, when's gonna be the exam? Is the same time, 8:15 or like earlier?
No, I don't know. It's what I forgot. I didn't look online. Does anybody know offhand?
I think it's 8:30 p.m.
Look in CUNY first. I would do it except that
Yeah, I think it's 8:30 p.m.
it's 8:30. It's
So
usually 8:30 to 10:30. I don't know why they make it so late. But Tuesday evening, right? In our classroom.
yeah.
Okay. Yeah, I think I might have written it down in the over here. Schedule. Did I put it down? I think I might have put that down. Anyhow, it's been a very nice semester. And yeah, I did put it down there. So it's going to be May 26th at 8:30 p.m. Okay? And if any questions, email me. And I'll get around to it either tonight or tomorrow. Okay?
Thank you,
So,
bro.
okay, so don't hesitate to email me. Okay? Okay, see you. Okay, bye.
Thank you.
Good night.
Thank you. Have a good day.
Good night. Okay, see you.
Good night,
Good
Professor.
night. Good night.